Has anyone read the book Outliers by Malcolm Gladwell?
Oh.
In general, if we're summing that up in a couple words, it's, success and opportunity is often due to conditions one finds themselves in, rather than necessarily an extreme amount of talent. There's good luck involved in opportunity. So I'm just an elementary school teacher that had a chance to practice Singapore math long before it was known on a large scale. 10 years ago, there was maybe a dozen schools in the country doing it. I was at a school, the first school in Pennsylvania to adopt the program, and I was incredibly lucky to be trained by an Israeli math professor who's more responsible for spreading Singapore math than anyone else. And what I'll do is I'll share a few things I learned, but I also want to put out a disclaimer. One, this is a 100-hour course in Singapore. I can't possibly educate you perfectly on this in the next 30 minutes, okay? So what I'll do is I'm going to do a few overview things. I'm going to teach a little math that I think is integral to the K2, a strand that is integral to K2, and then no later than 8:15, I will open up the floor for questions, okay? What I'm going to ask is this, please allow me to present. And if you have questions about what I'm presenting, let me know, or please ask. If the question is separate about homework, about, where will my child be in 2 years, things like that, please save that for 8:15, and I'll do my best to answer, and I'm certainly not going to rush out of here, okay? Great. So, where are parents of K students? Kindergarten, or pre-1, I'm sorry. First grade? And second grade? Okay, good. So let's talk a little bit about what Singapore math is. Now, in Singapore, they just call this math. Singapore math used to mean something very specific about 10 years ago. Now, it's hybrid into many different things. And the addition that was adopted here was called Math in Focus, okay? Like I said, I'm an elementary school teacher, all right? My background was in creative writing. I'm not a mathematician, okay? I specialize in elementary math at this point, okay? The professors I have talked to, and my experiences of having taught traditional US texts are this. Characteristics of most US textbooks, okay? They're often stigmatized as being a mile wide and an inch deep, okay? Topics aren't taught in depth, and often the practice is unfocused, repetitive, and unchallenged. Now, part of that is the geopolitics of America, okay? Things are changing a little bit now, but up until a couple years ago, you had 50 states, 50 different standards. What does that mean? Holt, Houghton, Mifflin, major textbook companies would have to write gigantic books so they could sell them from Alaska to Florida to Maine to California, okay? And therefore, mathematics education reflected these textbooks. Who can remember what their 4th or 5th grade math textbook looked like, or maybe even middle school? Can anyone picture it? Can anyone remember brown paper bag book covers?
Yes.
Good. And you tend to associate that with weight, thickness, and something you don't like to carry in your backpack, right? Okay. What that is, it is a reflection of 50 states and 50 states. You've got 50 chapters written by 50 different authors, or maybe 20 or 30 different authors, okay? I can sell that book anywhere I go. It's a marketing engine. Now, okay, that's encyclopedic, okay? Now, the other is a storybook. It's like a sitcom, okay? Think of your favorite sitcom from childhood. You could miss a week, and ultimately follow along whatever storyline came the following week, okay? You have a little plot, wackiness ensues, and everything comes back to the way it was when it started, okay? That's the other type of US text we traditionally have. Now, how is Singapore math different? Okay? Covers less concepts and more depth. It's a little bit bigger now. When I started, a little bit broader now, but when I started, a typical Singapore math on average covered 12 topics per year. A typical US book covered about 28. Okay, so over more than half less. Okay, what Singapore math does, it digs deeper into a few topics rather than glossing over many. Okay, the idea being that if we master something well, we're laying a foundation to build a higher tower of mathematics among our students. Okay, now how did Singapore math begin? I've never been there. Okay, but I do know it's a tiny country in Malaysia. Yeah. And in the 1965, I think it gained its independence from Great Britain, I believe. They don't have many natural resources. To build their economy, they had to use people as their resources. The government got together and decided we need to make our people highly educated if we're going to advance our economy. They hired a team of mathematicians from around the world to spend 10 years writing out a curriculum, a national curriculum, so that their children would become more highly educated than most of the rest of the world. They tend to do better in mathematics, they tend to do better educationally in worldwide tests. Now, so less concepts, more depth, okay? It works concretely, pictorially to abstract, okay? I have 3 books, okay? We can feel it, we can touch it, okay? Now, I can represent that with a drawing, a literal drawing, okay? I'm drawing 3 books. We work abstractly. This can also symbolize 3 books. And so can this. Okay. Concrete to pictorial abstract progressions. This would be a kindergarten topic, kindergarten concept, early kindergarten. Now, okay, the big piece, and often the point of frustration for teachers, students, parents, becomes this. Each concept builds on those that have been previously learned and mastered. A team of mathematicians wrote single authorship, they go to 10th grade, I think, in Singapore, okay, and then they're done in high school. Okay? A K, or a first grade through 10th grade curriculum, okay? This works like a novel, okay? There's not ghostwriters, 30 different authors touching first grade mathematics, okay? A single authorship takes the students on a story from 1st through 10th grade. It works like a novel, and in novels, there are twists and turns, okay? To understand the 10th chapter, we need to read chapters 1 through 9 and understand them, okay? Not necessarily so in traditional US text. So, I can anticipate a question, well, what happens if my child is starting Singapore math in 2nd grade, okay? Because they've already missed the first chapter of this novel. I will address it again later, briefly. It's not too late to catch up to a good book. Okay? It doesn't mean we don't read a good novel just because we're starting a little late. A child comes a little bit late in the school year. It doesn't mean they can't catch up with that foundation. It just will maybe slightly more challenging for a year or so. Okay? Some of the models that are emphasized, a deep understanding of the number line, a place value chart, which we'll get to later, and it is a unitary system which bridges into algebra nicely. And if I do this again in 3 or 4 years, we'll talk about that. Now, let's talk a couple models here, okay? First, the number line, or number bonds. This is an integral part of what students are learning in kindergarten and first grade. Okay? This is simply a graphic for a part-whole relationship. A part-whole relationship.
relationships, okay? Within this model, we can see 3 plus 2 is 5, 2 plus 3 is 5, 5 minus 3 is 2, and 5 minus 2 is 3. Okay, we got that all right, yeah? 4 number sentences, 1 model. This is the most important model of the curriculum, and an awful lot of time is spent preparing students to master it in kindergarten and mastering it in first grade. Once this is mastered, the rest of the program becomes much simpler to teach and learn. Okay? Later, mainly starting in 3rd grade, this segues into part-whole relationships with bar modeling. Okay, any you're of bar modeling? For that tends to be the one of the main associations with Singapore math. It's the bar modeling method for solving word problems. It's introduced in 1st and 2nd grade, but it gets to be much deeper starting in 3rd grade. And so here we've got this particle relationship. 30 and 20 makes 50. An advantage the bar model has, you also can see the difference, right? That would be 10. It weaves in another particle relationship within 20, 30, and 50. So I want to take us through a progression and share some of what your children will be learning as they work their way from kindergarten through 2nd grade. Could you take out this? And let's just cover. I'm going to do this. And if you very early on, if you don't have pennies, I may not have enough. I thought I had exchanged a $20 bill for them, but I don't think I did. So there may not be quite enough for everyone reading. But very early on, working concretely to abstractly, draw a dot if you don't have it, or just pay attention. Okay? Students come to associate this with an animal. Wow. Sorry about that. So this we can represent as 4. Now it is a 10 frame. And one of the powers of this graphic is this. Let's work with it. How many pennies are on board? 5. Very good. Close your eyes. Okay. How many pennies are there now? 6. Yeah. And you likely computed that much more quickly because you knew there were already 5. This is a connection to the best manipulator the child has. Okay, show me 5 fingers. Show me 6. I didn't see anyone in the room drop their hand. We've already learned to master. We've already learned that an open hand is the same as 5. It's one of the first great mathematical discoveries a child makes. Kindergarten teachers, pre-1 teachers, likely could divide their class into students. If you ask them to show them 5, they do this, and notice you can do that. It represents a great difference in understanding. Okay. 5, show me 5, show me 6, show me 5, show me 7, show me 5, a major part of understanding the 10 frame and how many this shows, phase 1, and also how many empty spaces there are. Okay. We have 9 pennies, there's 1 free space. 9 and 1 makes 10, 1 and 9 makes 10. Now, let's jump ahead. Use both parts of the word. Or should both parts of the word. And if you'd like to participate, I welcome you to, would you cover each dot with an How many are on the board? 10. Close your eyes. And how many are on the board? 12. Stated a different way, 10, 2. Right? Let's use. We've got 10. We've got 5, 10, 5, 10 and 5 is the same as 15. Okay. Introduction of numbers. Now, let's clear this and show 6. How many are on the board? 6. Add 3. And we get 9. Okay. 6, 7, 8, 9. Now, it becomes problematic if we always count on defining the answer. Okay? Because eventually we're going to want students to be doing problems like 37 plus 24. Yeah? And we can't always count on defining those answers. Or it will take a long time and subject to some error. So we've got 9. Let's, with no writing utensil in our hand, let's add 5. Now, raise your hand if you know the answer. Okay. The answer is 14. But as teachers of this program, yes, we want students to know the answer. Yes, we want them to know it quickly and easily. But we also want them to understand how it works and possibly more than one way it works. Okay? Now, you know your children. Okay? And my understanding of first grade in general, some would say, I counted to find the answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And a bunch of students will think, no, that's not what I did. I said, well, how did you count to find the answer? I started at 9, 10, 11, 12, 13, 14. That's correct. Can anyone see a different way to solve 9 plus 5? Yeah.
15, and then I see if there's one missing, so I hit that.
You see 15 take away, but there's only 14. How are you seeing 15?
Well, I'm seeing 3 sets of 5, but I'm seeing that one of the boxes is empty, so I know it's one less than 15.
So by filling this in, okay, you're seeing 10 and 1 less than 5, in a way, right?
Yeah.
Yes? Good. And that will be a more efficient way maybe to solve the answer, right? Good. Let's try a different problem. Show 7. Show 8. And let's add 4. We can find by counting on 8, 9, 10, 11, 12. We'll leave them at 10. 8 plus 4 is 10, and 4 take away 2. Questions about the model? Questions about anything? Would you turn the graphic around? And show this. Let's format this just a little bit differently. Let's show 9 again. If you don't have pennies and would like to draw dots, do so. If you'd just like to sit here and watch, I completely understand. The program works concretely to pictorially to abstractly. I'm not sure what I can do. How many pennies do you see in the 10 frame? 9. Good. So I'm going to symbolize that with a 9. Let's add 4. Okay. Now, you could do one method, 9, 10, 11, 12, 13, right? But we do Mark's method. And what was Mark's method? He had to make a 10 strategy, right? And so Mark's theory of adding, crossing the 10 is we first make a 10. Shift the penny. Now, record what you did. Nine plus 4 is the same as 10 plus 3, or 13.
I do that.
Questions? One thing I'll say before, just it may be your question, may not. Don't mistake a format for the actual mathematics. The child that understands the make a 10 strategy understands the mathematics. This is one way, there are other ways, this is one way to express that understanding at the abstract level. Yes?
The concept of make it 10 is still, it's below second grade, correct?
First grade.
So, when they're starting in second grade, they're not learning make it 10. They've already
They
gone past that.
are in a different level.
Okay,
They are with a different level.
okay.
Anyone else? Yes?
But it looks like to me that you've gone from 2 math problems to sort of asking the child to do one math problem has to do 2 math problems.
9 plus 5 to seeing
So now it's
9
9
plus
plus
5
1
is-
plus 3.
9 plus 4 as 10 plus.
Well, seeing 9 plus 4 as 9 plus 1 and 10 plus 3, which if it works, it's great. I'm just wondering if that's, is it
I wouldn't call it 9 plus 1. I would say we're breaking apart a 4 to make a 10.
okay, but it's still 9
So we're
plus 1.
subtracting.
Because you're subtracting 4 minus 1,
Okay.
and then you've got 9 plus 1. I guess I don't think that's a bad thing. I actually think it's really, a great way to conceptualize it. But I'm also wondering, does it get complex in terms of the sort of number of math problems you're asking the child to do with one addition problem?
I want to, I'm not debating, let me see if I get there.
You get there
One,
another way.
I've not discounted counting on. 9, 10, 11, 12, 13.
I don't want to.
A legitimate strategy. Another strategy is to make it 10. That doesn't mean there's not other strategies out there. And then, sorry.
I don't think that was my question really. It's more that I don't want. I know you got to get the opposite to counting on. The question is more. Does going from a sort of a simple question of 9 plus 4 and then turning it into moving the penny from 4, so I'm subtracting it from 4 and adding it to 9 to make it 10, and then adding that new 9 plus 3 together, 10 plus 3 together. Have you found that am I adding a lot of complexity that perhaps maybe no one else?
Are you adding the
And maybe I am. Maybe I'm the only one who thinks it's a little more complex.
Just the kids are going through more processes, you're saying.
Yeah,
to solve
exactly. To
it.
get to the.
Go ahead.
So
Yes.
maybe.
Okay, I think, I see it, this is how I do it. So, what I think that one, that it's visual, changes everything, and 2, it becomes second nature to them. It might be just hard at first, because it's like riding a bike, you have to learn it, but then it just becomes second nature. So it might be that extra stuff right now, but later they don't, it's gone.
But I think Sharon, you're right, it's the visualization of it. You're now all of a sudden looking
I
at an
try
image
to
rather
explain
than
like
a
this,
map.
just keep the one. But I think that if I showed them with just from this paper, they would understand it faster.
Don't forget your brain is also process technology.
Differently,
We don't learn
I know.
that.
I'm not saying it's a
So
bad
it's
thing.
probably easier
I'm
for
asking.
them to-
Right. No, I understand.
what
But
you're
I'm
saying.
asking you, is
It
this
is an
adding
extra step in the
complexity?
study.
And how does that change? Like, are you
I
finding
will say
any?
this, it is very hard to conceptualize this if you're not very comfortable breaking apart numbers and composing them. And therefore, a lot of work needs to be in place before this. I have found that very few first graders can't understand the conceptualization of this. Think in terms of a video game. Level 1, we work at it concretely. You've mastered that, you're ready for a new challenge. Can you now shift and find the answer? Can you now shift and write another addition sentence? Next level.
So you're not starting off at the
Starting at the concrete level. And now can you format with it? Yes?
So I have a question.
A little louder, please.
It might be for the next level, I'm not sure. But for how long do you work with the picture of the groups of 10?
Excuse me?
How long would you be working with the groups of 10, and how do you then switch to doing this in your head? So how
That
would
depends
be-
on different children,
What's the
different
trick,
classrooms,
though?
different teachers, different.
What would be like the trick, the concept?
We understand at the concrete level, we work at the pictorial level. We understand the pictorial level, we work at the abstract level.
So you're just getting them used to getting to 10 or to 20 or 15 numbers that they can play with, and then they just do it with their head afterwards. They don't. I just
We
want to know
want
what
the same
jumps
result.
from-
We want the same result. We want them to understand the abstract. We want them to see 9 plus 5. I don't remember how I learned 9 plus 5, but I do know the answer and I can conceptualize it. So we want students to arrive basically at the same understanding we as adults have. But but most of us skipped over, our education skipped over the process of how to arrive at it. Now, you can vary, a common question, a common pushback I'll receive is this. Why in the world do this when we really just want them to know that 9 plus 5 is 14? Why don't we memorize it?
No, that is brilliant. I mean, you get the actual. It's like a play. It's like a game.
Well, okay, and great. If you feel that way. If you don't feel that way, I'd like to speak to that. I appreciate that. This helps us solve other things, okay? Let's look at a place value chart, okay? Now, if we take a number, I'll say this symbolizes a 10. So that number is what? 5 tens is the same as 50. I'm going to symbolize that, right? And so what number would this symbolize? 5 tens, 4 ones is 54. Now if I want to add 2 tens and 1 1, what number am I adding to 54? 21. What I do to the picture, pictorially, I do here. If we had an infinite amount of time and resources, I would have you actually physically holding the blocks. Okay? Anything that I'm drawing, we could actually be holding. Yeah? Little cubes and 10 sticks. Okay? 4 ones and 1 1 is 5 ones. 5 tens and 2 tens is 7 tens. 54, 5 tens, 4 ones plus 2 tens, 1 1, 54 plus 21 is 75. Okay? Now, if we dig in complexity, let's take the number 59. And let's add, 15. 9 ones and 5 ones is 14 ones, right? 5 tens and 1 tens is 6 tens, but that's not how we write it. Is the answer 6 tens and 14 ones?
Yes.
It is, but it looks like 614. So we need to teach a format to do this, right? See, okay? we bundle the 10. Exchange it for a 10. What I do with the picture, I show in the numbers. Yeah? 110, 5 tens, 110 will give us 7 tens or 4. So the integrity with which 9 plus 5 is taught can help us learn something more complex a year later. Yeah? Where are the second grade parents? Good. Now, give me 1 second. I need posters so that you can keep this model up. We understand the concept of bundling to 10 and shifting. Yeah? Okay. Now, so the question remains, the second grade teachers, why in the world do we need to go through all this when really we want our students to memorize add, carry, add? Okay. Now, can this model help students learn something that more complicated in third grade? I think so. What number did I represent? 24. So if I multiply this by 3, that would be 3 sets of 24. 24 plus 24 plus 24. 2 tens, 4 ones plus 2 tens, 4 ones. Plus 2 tens, 4 ones. Yeah? What is 4 ones times 3? 12 ones. What I do to the picture, I symbolize. 2 tens times 3 is 6, plus 1 is 7 tens. But the integrity with which we teach and learn the addition algorithm will help us in the multiplication algorithm too. 5th grade, when we learn something with numbers less than 1, okay, the decimal system will continue to work. Questions, comments, thoughts? Yes?
Would you know how you do a subtraction problem using this method?
Glad you asked. With this? Yeah.
With the carry.
Yeah, yeah.
What's that?
With the carry.
With the carrot. So we like 42 minus 13? Is that okay? Good. This is 4 tens, 2 ones, take away 1 10, 3 ones. Do I have 3 ones to take away? No, I only have 2. So I need to unbundle a 10. Yeah? What I do to the picture, I symbolize. 42 is 3 tens, 12 ones, yeah? Now can I take away 3? Can I take away a 10? Yeah?
Beautiful.
Does this help us solve something with division? Yeah. Let's take 35. Divided by 2. There are several ways to do this. I don't want to spin into a discussion too deep. Can we accept that there are 2 ways to divide, and one of the ways is to make groups? Good. So this could be how many groups of 2 tens is in 3 tens? I grouped, this is one group of 2. Yeah? Okay? Now, 2 tens is the same as 20, right? Good. I now have 1 10 and 5 ones. Can I make a group of 2 out of 1 10? Only if I break 1 10 apart. So I need to unbundle it. Oh, sorry, these were supposed to be. Yeah, I'm sorry. So can you see okay?
Yeah.
Can we make, how many groups of 2 ones can we make out of 15 ones? 1, 2, 3, 4, 5, 6, 7. What I do to the picture picture, I do the numbers. There's a different way to do it, and if that's bothering anyone. Okay, there is a different way to do it, and I can share it. I'm not sure it makes sense with the amount of time. Now, 35 divided by 2 is 17 with a remainder of 1. Okay? Now, in 3rd grade, I learned this, and I tended to do pretty well with algorithms. I was not a great master, but I did do well with algorithms. What did I learn? Well, in 3rd grade, we're going to teach this and master it. In 4th grade, we're going to continue to master it. And then in 5th grade, I was introduced to decimals, and my 5th grade teacher says, remember the whole thing we're learning with that remainder? You're not doing that anymore. I now want you to draw a dot, drop down a 0, and continue to divide. We remember learning it in some level on that, right?
Yes.
What was the teacher actually telling me when they said dot, tack on a 0?
Break down.
Can we make a group of 2 out of 1, 1? No. We need to unbundle the 1 and make 10 tenths, right? So the integrity with which 2nd grade teachers, 1st grade teachers teach subtracting and adding, crossing the 10, builds a foundation for 2nd grade, okay, to learn the addition and subtraction algorithms, which helps students understand the multiplication and division algorithm in 3rd grade, and then better making sense of this in 4th and 5th grade when we're working with place values to the right of 1s. Okay? So anyway, there's another 99 and a half hours to go, but why don't we stop there? I promised 8:15 and I've already proven to lie. So does anyone have any questions about this or the curriculum in general you'd like to ask? Yes? Yeah.
So, our school goes up to 8th grade.
Mhm.
Once 8th grade, we're dispersed to the winds. I mean, there are certain
Yeah,
schools that we all
and
go
they
to, but.
apply, yeah, for new admissions.
Right,
Yeah.
so if the high schools haven't adopted this approach, how prepared are the children for the advanced math that gets taught in a different way?
Sure. I'd love to put up data right now, and I can't, okay, and I don't have it. My experience is this, okay, having taught this with actually a group of students who began in 5th grade, okay. They had 3 solid years, 5th, 6th, 7th grade. It was a little late in the game for some of the students. I can't say everyone became a great mathematician. However, I found that while other students were taking pre-algebra, they were staying with Singapore math. They made up the ground with pre-algebra and algebra very, very easily because their number sense and conceptual understanding was so strong. You know, and I'm hesitant to say this because I usually work with just case 6. So I'm not an Algebra 1 expert. I know algebra. I'm not an Algebra 1 expert. Most of it is formatting. And a child with strong number sense and conceptual understanding tends to be able to catch up with the formatting quickly. That's my experience with it. But I don't have data to give you. I could refer you to people who may have the answer because there's many schools that have been doing it for 3 or 4 years, 4 or 5 years now. There's a question in here as well.
I just wanted to make a comment.
Yes.
One of the reasons that we decided to go with Singapore math was because of the foundation that you're talking about, the number sense. I taught 6th grade for a long time here, and one of the things that would drive me insane is when I had last year I taught the regular class, when at least 70% of my class would regroup the problem 105 minus 9. They would actually do the whole regrouping, and they couldn't see 9 is almost 10. Let me take away 10 and that. They could not see how to break apart numbers, how to work with numbers. They got the right answer, but they had no number sense. And at some point, that ended up hindering them. So that was when we were looking at the programs, that was one of our big, the big focus for us is a program that really is going to start building from kindergarten that number sense where kids are going to be able to go into pre-algebra. And when they have to solve an equation, they're not regrouping simple numbers. Okay. Does that make sense?
Yes.
I have a question.
Yes, sir.
So, until now, this school is not teaching that way,
Right.
right? This, of course, it has to be like that. That's how we learn in Israel, and that's the best way, of course.
You missed what he said, that he was trained in Israeli
No,
mathematician.
there's not even a doubt about it.
I
That's the
just
way it
have
should
to
be, and
say, I
period. You
told my
don't even
husband,
give an option to the school. It has to be like that.
It's mathematics, yes?
Just because they did it in Israel doesn't.
Yeah. Is there a question? Yeah.
Can you describe what unitary system means?
I knew you'd ask that. It's very hard without getting into bar modeling, and I think it's a longer discussion.
Okay.
Basically, students, what do? We created a unit of 10,
Yeah.
okay? I've got 12 apples. Okay, I have 4 times as many apples as you. How many do we have altogether? Okay.
Unitary is sets? Sets.
We're constantly looking to find one of a unit to find more. Okay, so before finding 5 units, we need to find one. That's one example. Yeah. Yes.
So this is a number sentence for addition, right? So how would it work with division? How would you write that out?
You wouldn't.
You would.
It's a different model.
Oh,
Yeah.
so how does that work?
Sure. Yeah.
Okay, so now our kids are in second grade, how does it catch up?
How do they catch up? Well, they have a long time to catch up. Okay, so no, this is a journey. Okay, so I'm not running the school, so I've never experienced a school day here. So whether or not there's an action plan, I can't answer that. I can offer suggestions. What my recommendation would be for the second grade teachers is this, okay? You continue teaching second grade, and as you find gaps in understanding, you go back and fill in those you don't go back to first grade and start teaching over, or you'll never get anywhere. We're on this line, we occasionally plug holes and come up.
So for instance, if you see that there's stuff on 9+5, then you show them this.
Sure.
Like that kind of example, like,
The teacher is the professional in the room.
sure.
So whether or not they do exactly what I just showed, you could teach the curriculum without ever using that insert. It's the concept of making 10. And yes, if students are having conceptualization problems with grouping a 10, before trying 29 plus 15, 9 plus 5 is a very logical place to start. Okay? And it doesn't mean that needs to be a long hole being plugged, but we dip to first grade to get back on the track we want. That's teaching that's teaching mathematics, not necessarily single things. We constantly need to be building ladders below the grade level to bring us back to grade level. A more intricate plan, again, I'm not going to go through it today, but I know, I will be supporting the teachers somewhat tomorrow. I can't give them a 100-hour course tomorrow. So anytime you do invest in a new program, there is a learning curve. There's no question about that. And however, I think they did choose a very good curriculum, and I wouldn't view your child as a guinea pig because they're starting in second grade. There's plenty of time for them to develop very, very well, and a good program is still going to trump a weaker program that they've been in for several years. Yeah?
So just wondering, so you said that this goes up all the way to the end of high school?
Math and focus, I don't know where it ends, but I'm not positive. I usually work just K-6.
So is there a different method of teaching, like pre-calc and calculus, like derivatives and then?
I don't know pre-calc and calculus. Algebra is algebra. You can choose what book there's going to be a little variation between textbook companies, but that is a calculus. I never completed calculus. Okay, I believe that is its own subject. It's going to be taught fairly similarly, but I'm not positive. Algebra, there's not much variance between the two. So I don't know what school will select 3 years down the road, and that's a decision for a later time. Yeah?
So I'm just curious, you know, when you get to the higher level math like he's talking about, there is like certain order that you need to do things sometimes. And so how does it, like if the kids up until 6th grade are like, oh, well, we've been finding the answer in any way that suits our thinking process, and now all of a sudden you have to follow a model, how does it fit? Do you know what I mean?
It's hard to answer without specifics. There's a lot of models and a certain grade. So I guess there's some vague in I guess what I'm hearing. I'll give one. Let me share one example. We can model Bill's money. What is your name?
Deborah.
And Devorah has $7 more than Bill. Yeah? So this is Devorah. This is Bill. Right? You are just... And all together, we have $37. 2B plus 7 equals 37. The role of, say, a 5th grade teacher is to bridge from what students have been learning. Okay? This would be your unit, right? Your variable. Okay? And yeah, then students understand this is 37, take away 7 is going to give you 2 of Bill's money. And we teach a format to get 2B, equals 30, right? I've been sloppy, I apologize. So if these 2B units equal 30, we divide by 2 to find our answer. Okay. I chose something pre-algebra, and I will be able to answer questions like that better in the context of that, say, algebra 2 or calculus.
I just want to add one
Go ahead.
answer to Deborah's question. Part of our committee involved input from our middle school staff. So we have Mr. Klein, who teaches 6th, 7th, 8th grade accelerated algebra in 8th grade. And he actually teaches the bar modeling method in his classes. He was a huge advocate for Singapore math and really feels that the foundation that you get in Singapore math helps the kids do better in algebra. So for those kids who have had him starting in 6th grade, without having any of this in the elementary school, have learned at least the bar modeling to solve word problems and are using it beautifully.
So, I mean, I can see how this is a far deeper level of understanding with respect to numbers and how they actually translate to the real world. My question is, when you first started out, you said the way that American math is done, it's very shallow but very broad versus Singapore math, which is very deep. But
If I didn't say that is a general stereotype.
Okay.
I don't want to be.
well, no, but I don't
Okay.
actually disagree with that.
Yes.
What I would want to know though is, or what I do want to know is, how does the curriculum in each grade level match up to what is expected of
That they
a
will
child by the state? for
Sure.
example?
So I said originally, it was 12 topics versus 28. This has become more mainstream American friendly. Therefore, I don't have a graphic to show you right now of how it breaks down. Most concepts are it has been Americanized to the point it's Common Core aligned. Some schools are just not, but the standards are being met. And if not, there are a few things, not a.
So somebody who completes the 2nd grade in Singapore math versus someone who does it the other way.
They'll likely be ahead. If they completing a grade
Right.
without that, yeah, if they've mastered the content, I think they'll be well ahead of the typical
Oh,
student.
okay, that's good.
Thank you. I was gonna say one thing as a teacher, I teach 1st grade here, I just started, and And one thing that I do see though in like 6th, 7th, and 8th grade is you have kids walking around saying, I don't do math. I don't know math. I'm not saying in this school, I'm just saying in general in schools. And I hear my kids' friends, and I haven't gotten math since I was in 2nd grade. And I think that a lot of it comes down to them not being able to really understand the math in a concrete way. So I could see how it might not help them each of these concepts in calculus, but it will carry their love for learning of math or the interest in math enough to get them to a place where then if they have to learn a methodology to it, or they have to learn steps in a math, at least their interest in the subject, their capability or their confidence in the subject is still there by the time that they get there. I see a lot of kids that I think their confidence in math is crushed at a certain point, and this kind of allows them to understand and explore the math concepts on their own and really understand it on a deeper level.
I am not leaving. I know some people may want to leave. I have a request before you go. If you could leave the board the way you found it, I need to be back in not that long from now. You would save me 20 minutes if your board looked like that. But continue asking questions. If you would take the inserts out immediately, I'd appreciate it. This is a white side and orange side, pennies, marker, eraser would be wonderful. But please continue to ask questions. If you're leaving, please do that. Yes. Okay, thank you. If you want to come approach me and ask a question, that's fine. Do you have a question, Kurt? Go ahead.
So there's a couple more questions.
Yeah, go ahead.
Not really a question, sort of just being, I'm dyslexic. And I had a horrible time in school learning this. Now I'm an engineer in computer stuff, so I pretty much learn my own tricks. And I'm just really excited. I'm really fascinated. This is brilliant because it's a trick. I had to learn stuff when I was 20 to get this. And I was really behind all of the years when I was in school. And this is just, I'm just all excited. I'm really happy that my kid is going to do this.
So I want to just, before, I know some people have to leave, you're welcome to stay, but before everybody jets out, I want to thank you, Bill, so much for coming and doing this with our parents, and I want to thank all of you for really coming in and supporting us. It really means a lot. Feel free to ask.
I think making a 10 work in number sense they can possibly get.
We know that. Oh, yeah, okay.